Hello, so today we're going to be doing lesson 1.3, solving equations with variables on both sides. So we are used to seeing, let me grab my sheet of paper here. We are used to seeing things like this, 3x minus 11 equals 21, okay? You're used to seeing an x or a variable on only one half of the equation. Remember, this equal sign divides the two halves of the equation. So we're used to seeing a variable only on one side. So now what this lesson does is this lesson has variables on both sides. So it'd be something like this. 3x minus 11 equals 7x. Okay? So here's what we're going to do in this lesson. We are going to try to physically move our x's together. Okay? And now how we do that is it's exactly like how we would move things over without x's on both sides. Before I get too ahead of myself, what are the terms of this equation? We've got 3x, that's a term. We've got negative 11, that's a term. And we've got 7x, that's another term. Okay? Now these terms are separated by this equal sign right here. But I see like terms. I see 3x and 7x. So what I need to do is physically move that 3x over to the 7x. And how we do that is we do the opposite of what it is. It is positive 3x, so we're going to do the opposite, which is to subtract 3x. But now if I do it to one side, I have to do it to the other. These two would cancel out, which would leave me with negative 11. And then we just go ahead and subtract these. 7 minus 3 is 4x. And now I just made these numbers up off the top of my head, so it's not going to equal a nice thing. But now my job is to just get the variable by itself, just like we had been doing. What's happening to the variable? The variable is being multiplied by 4. So the opposite of being multiplied by 4 is to divide by 4. And I would do that to both sides. Okay, so now I have x by itself, and then we have negative 11 over 4. How many times does 4 go into 11? Well, it can go in 3 times would be 12. That's too many, so it can go in 2 whole times, which 4 times 2 is 8. 8, 9, 10, 11, so it would be 3/4. But a negative divided by a positive is still a negative. So my answer would be negative 2 3/4. Okay, so that was just an example of what we're basically doing, and I'm going to do a ton of examples with you so that you can just keep having that practice, Please take notes of these examples, and I'll try to go slow so that way you can figure out what I'm doing, but also remember you can always pause the video. Okay, let me go ahead and section this off real quick. So here's the first example. It says solve 15 minus 2x equals negative 7x. So just like the one I just did with you, I've got variables on both sides of my equation. Now the terms, we've got 15. Another term I see is negative 2x. And then I see another term of negative 7x. But then I also have this barrier, right? So those terms are not on the same side. I want to get my x's all together. Now I can't move 7x over here. And the reason why is because if I did add 7x to get rid of it and add 7x over here, my new equation would look like this. Nothing. There can't be nothing on this half, right? There is nothing here because I got rid of the 7x, okay? That's why I can't move 7x over there. I have to move the negative 2x to the other side. Can't have an uneven equation. So let's go ahead and move the negative 2x to the other side so our x's are all together. The opposite of negative 2x is positive 2x, so we're going to do that to both sides. Negative 2x cancels out with 2x. Negative 7x plus 2x. Signs are different, so we subtract. 7, 6, 5, so it's going to be 5x, but 7's the bigger number. It happens to be negative, so my answer will be negative 5x. Now, this is just like what we had been doing, right? I just have a variable, something's going on with it, I gotta get that number away. 5 is being multiplied to the x, so the opposite of that would be to divide the negative 5 to both sides. Those two cancel out, make a 1. 15 divided by negative 5 is negative 3, and then I've got an x on the other side, and that's my answer. X equals negative 3. Okay? So that's what this whole lesson is about. All we're doing is we are moving x's variables together and then solving it just like we had been doing. Let's go ahead and do this one. Negative 2 times x minus 5 equals 6 times 2 minus negative half x. Now, just go ahead and work on 1/2 at a time of this equation. Let's start with the negative 2 first. I need to distribute this through, and then after I'm done with that, then I'm going to distribute my 6 through. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. Now let's go to the other half. 6 times 2 is 12. 6 times negative a half. Remember, if you're ever timesing by a half, it's the same thing as just dividing it by 2. So that's going to be negative 3x. Okay, now this problem looks an awful lot like the problem we had just done up here. I've got x's on both sides. Here's the difference, though, between this problem and the problem we had just done. This time, it doesn't matter if I move the negative 2x over here or if I take the negative 3x and put it over here, because I will still have terms on each half of the equation. So it's not like I'm going to leave 1/2 completely blank. Now, I like to work with positive numbers, so I like to see I like to move the x's of which one's going to make me a positive. For example, I would probably add the 3x instead of add the 2x to the other side, because negative 2x plus 3x gets you one whole x. And I like working with positive numbers, but you could have moved it the other way too, and it would still get you the right answer. Now bring down the stuff we haven't used. Now this is just a very simple problem. How do I get x all by itself? Do the opposite of what's happening to it. It is being added by 10, so subtract the 10. But if I do it to one side, I gotta do it to both sides. These two cancel out. 12 minus 10 is 2.
Sophomore be released to head to the library to meet with the Jostens rep, please. All the sophomores head to the library.
Sorry, there's an announcement on the speaker. All right, x equals 2. That's my final answer. So remember, it's just like what we've been doing. There's just an extra step of getting your x's together. We can do a few more example problems together. I think that's the best way to learn this, is just to keep doing it over and over and over and over again. Let's go ahead and do this one. Negative 3x equals 2x plus 19. Get your x's together. Now I'm not going to move this one over here. And the reason why is because then it would leave this half of the equation completely blank, because it would be gone. And I can't do that. So I can move the 2x over here, and that way I would still have something on this half of the equation. Now, how do I move 2x over there? You do the opposite of what it is. It is positive 2x, so the opposite of that is negative 2x. Do it to both sides. Those two cancel out, which leaves me with negative 3x minus 2x. Signs are the same, so you just add. Keep the sign they both have. All right, now it's just another simple problem. X is being multiplied by negative 5, so we're going to do the opposite of that, which is to divide by negative 5. Okay, now I know my answer is going to be negative, because a positive divided by negative is still a negative. How many times can 5 go into 19? Well, 4 would be 20, so that's too many, so we'll say 3. 3 times 5 is 15. Subtract that from 19, you get 4/5. So that would be your final answer. Let's do another one. 2.5y plus 6 equals 4.5y minus 1. All right, my job is to get my x's together. Now it does not matter on this one. I could move this guy over here, or I could move this guy over here. Doesn't matter because I'll still have something on either side of the equation. But like I said, I like to work with positive numbers. So my brain automatically says, let's move that 2.5y over to the 4.5y. Now to do that, you do the opposite of what it is. It is positive 2.5y, so we're going to do negative 2.5y. So that leaves me with a 6 on this half. Over here, it's just a simple subtraction problem. 4.5 minus 2.5 is just a 2. Keep your y. And the negative 1. Okay, how do I get y by itself? I don't divide by 2 yet. I have to get rid of that extra stuff first. So we're going to add the 1 to both sides. Now divide by 2. Y equals, how many times can 2 go into 7? It can go in there 3 times, because that would be a 6, and 1 left over. There we go, and it's positive because there's no negatives. All right, now that's all great, right? This is just like the basic idea of how to do this. Now the second half of this lesson tells us that sometimes when we're doing a problem, our x's cancel out and something weird happens. So let me show you. This is super, super important. Hopefully you're listening really well. This is just like what we've been doing. Get my x's together. I can move either one, which is great. I'm going to do the opposite of what negative 4x is, which is plus 4x, and that'll cancel it out. But if you notice, it cancels out on both sides. Negative 4x plus 4x, that's nothing. So what I'm left with is 3 equals negative 7. Does 3 equal negative 7? No, those are not the same numbers. That's silly. So your answer is no solution. Okay? So when you get things like this where the x's cancel out, you're not doing anything wrong. This is perfect, okay? But it just so happens that 3 is not negative 7, so the answer is no solution. Now there's ones similar to that where the x's cancel out. Here's a perfect example of that. Let's do it right here. Let's go ahead and solve for this guy. I see a distributive property problem I have to do first. 4 times 3 halves. Change that 4 to a fraction. It's going to be 12 over 2, which is the same thing as 12 divided by 2, which is 6. So that is 6x. 4 times 1 is 4. So now I'm just going to rewrite what I haven't used. 6x plus 4 equals 6x plus 4. I've got to cancel out my x's. So I'm going to move this guy over to here. So I'm going to subtract 6x from both sides. Now if you're noticing, the 6x's and the 6x's cancel out, which leaves me with 4 equals 4. 4 is actually 4. So this isn't a no solution. This is called infinite solution. Okay? So if your numbers equal each other, that's infinite. If they don't equal each other, it's no solution. So that only happens when our x's completely cancel each other out. So the assignment that the kids did was on page 23. These first problems right here, every single one will have a solution. But then over here, some of them have a solution, while some of them have no solution, and some of them have infinite solutions. I'm just going to pick a random one real quick. Let's look at 21. 21 says half of an x plus half of an x equals x plus 1. Now, half an x plus half an x, that's one whole x. So I actually have x equals x plus 1. Okay? How do I get my x's together? Well, I can't subtract this x over here, because then it would make it totally cancel out and nothing would work, right? So what I have to do is move this x over here. What's the opposite of positive x? Negative x. So we're going to do negative x to both sides. But what you're noticing is if I have an x take away an x, what does that equal? Nothing, right? 0. Bring down what we haven't used. 0 equals 1? Is 0 equal to 1? No, that's silly. So the answer is no solution. Okay? So do you see how some of these work out that way, where you just don't have an x anymore? The x's went away completely. So now I'm just left with random numbers. 0 is not 1. Now let's say there was a 1 on this half. Then the answer would have been 1 equals 1. And then it would have been infinite solutions. Okay? All right, so that's basically the gist of lesson 1.3. Go ahead and rewatch this video if you need it to go through slower, or if you want to just try some of these problems on your own. They're on page 23 and 24. But that's the gist of lesson 1.3. All right, bye.